Welcome to Code Math Academy. So in this video, we will be solving the PYQs of ISRO scientist exam. So this is the part 1 video in which we will be covering 30 plus questions, and by solving questions we will be understanding the concepts. So let's get started with question number 1. So it is very much a basic question. It is based on the set theory. Now, so here we are given with A. A is a set with the elements x, y, z. Then one more set is given, that is B, in which we are given with u, v, w, x, and one universal set is given in which the elements are s, t, u, v, w, x, y, z. Okay. Now what we have to find is we have to find A union B bar intersection with A intersection with B. Now first we will be solving this. Okay. Now what is the set A? Set A consists of x, y, and z. Okay, and what will be the B bar? Now let's write the B bar. What is B bar? Every element in a universal set except the elements present in B. So whether S is present, now we will be seeing this यूनिवर्सल सेट. हम ये यूनिवर्सल सेट देखेंगे और इसमें जो भी एलिमेंट्स बी में नहीं होंगे वो हम बी बार में लिखेंगे. सो फर्स्ट वन इज एस विच इज नॉट इन बी. देन टी इज ऑल्सो is not in B. Okay, then this U is present. See, U is present in both, so we will be not writing U. Then V is also present, W is also present, then X is also present, then Y and Z. So this is the B bar set. Now what we have to perform? We have to perform union operation of these both. So what will be the union operation of these both? This will be, now what is union operation? Union operation means we need to write all the elements of the sets uniquely. Okay, then X is present, we will be writing X, Y, Z. Okay, all A set I have wrote. Now S is also there, T is also there. Okay, now this much only the set. Now you will be thinking why I have not write Y and Z, because it is already present. And what is set? Set is a collection of unique elements. Okay, so X, Y, Z, S, T. This is our A union B bar. Now what we have to find? We have to find A intersection of B. What does this mean? The common elements present in set A and set B. So which are these elements? X is there. Okay, then Y is not present, only X is present. Okay, now what we have got? A intersection B bar, only X we have got. Okay, now we will be merging the answer. Now what we have to find? We have to find the intersection of A union B bar and A intersection with B. Now whatever are the common elements in these two sets, that will be our answer. So I can see common element is only X. So X should be the answer. Now we will check the options. So option A is wrong, B is wrong, C is wrong, D is also wrong. So 100% correct answer is none of these. So in many times in these PYQs we will be seeing that none of these options is correct. Okay, so this was very much simple question which was based on set theory. Now let's move to the next question. So, and also if you have any doubt in any specific questions, then you can comment me. I will surely answer. Just mention the question number. I will surely answer the question. So question number 2 is minimum number of NAND gates required to implement the following binary equation, and the equation is given A bar plus B bar, means A bar ORing with B bar and C ORing with D. Okay, Now, instead of directly means drawing the logic gate, means NAND gate, we should simplify this binary equation. So there are many ways. Uh, so now I can write a bar like this also, or like this also, but I will be preferring this. Okay, there is no any difference between this and this. Hmm? So now a bar plus b bar and c plus d. Okay. Now I will be simplifying this, so I should able to uh, draw the minimum NAND gates. Okay, then we will be using distributive law, so that will be a bar plus b bar. Okay, and in bracket c plus a bar plus b bar. This will be also in bracket, and here will be c. Now if you can observe, this is also the NAND gate, right? This is the NAND gate, but using De Morgan's law, I will be converting it into actual NAND gate standards. Okay, actual NAND gate standards I will be converting. So what is that? This will become AB and means single bar for both. Then C plus for this also same. So this is the rule in logic gates, means A plus B bar is equals to AB bar. Okay, and similarly, if A bar dot B bar, what does dot means? Add. This becomes A plus B bar. Okay, so this is the rules in logic gate. So we have been used this rule. Okay, now using this we can draw the minimum NAND gate. Okay, now I will be drawing uh, the NAND gates required. So for these equations I will be drawing the NAND gates circuit diagram. Okay, now the circuit diagram will be like this. This is the C, then this will be the A, then B. Now this is NAND gate, right? So in this there is NAND gate. Okay, then this NAND gate will be connected with this, because this has also become the, in this between also we will be using the NAND gate, right? And we will be forwarding. So similarly here will be the D. So we will be also straight here also we will be using one more NAND gate, and the output of AV will be also connected to this, and this both will be connected to one more NAND gate. Okay, so now we will count the NAND gates. So this is number 1, 1, 2, 3 and 4. So total minimum required NAND gates are required is 4. Okay, 4 is the correct answer. Right, answer is 4. Okay, now let's move to the next question, which is based on tree. Okay, an array tree is there of depth n. Now let's see the question. This question is from data structures. Okay, and this last question was from logic gates, or we can say digital electronics, and this question is from data structures. So let's read the question. question is of the following, which best approximates the ratio of the number of non-terminal nodes in the total number of nodes in a complete k-array tree of depth n. Okay. So basically we have to find the ratio of number of non-terminal nodes. Okay. Now let's see what is non-terminal nodes first. Now let's see non-terminal nodes. Non-terminal nodes. So these non-terminal nodes are basically internal nodes. Okay. If suppose I will draw a tree diagram A, B, C, D, E, F, G, H, I. Now, what are non-terminal nodes? The nodes which are internal. Now, which are internal nodes? These all are internal nodes, right? And whatever these leaf nodes are there, these leaf nodes are known as terminal nodes. So, what should be our approach? That in any k-array tree, if okay, if we know total number of nodes, right, and terminal nodes, then easily we can find the non-terminal nodes, right? Now, for any k-array tree, there are there are formulas to find or what is the total number of nodes. So all these formulas are already derived, okay, and means in for the revision purpose we should remember these formulas because these are very important. Now if we try to derive the formula to find the total number of nodes in a tree, it is too much difficult and the time is not sufficient. Okay, so we should remember these formulas. Now let's see. So first of all, what we will be doing is, what is depth of k-array tree? Hmm? Now, how we can find? First of all, we will see how we can find the ratio. So the ratio can be find using non-terminal nodes upon total number of nodes, right? Ratio. Now these formulas are already defined. So directly I will be writing. So and try to remember this because these are very much important formulas. Total number of nodes in k-array tree is, what is that? T is equals to k to the power n plus 1 minus 1 upon k minus 1. Okay. Now in this, so this is the formula to find the total number of nodes. Okay. Now, and there is one more formula to find the leaf node. So to find the leaf node, the formula is k raised to power n. This is the formula to find the leaf node. Now, as we have the terminal nodes. Okay, we have total number of nodes. So using these two, we can find the non-terminal nodes, right? Let's find it. Okay, so I will be writing non-terminal non-terminal nodes is equals to, what is the formula? What will be the formula? Total number of nodes minus terminal nodes, right? Okay, now, but what we have to do, we we do not have to find the exact value of non-terminal nodes. We have to find the ratio, right? I will show you the question. So what, which best approximates the ratio of number of non-terminal nodes. So they have not asked us that how many non-terminal nodes are. They have just asked us the ratio, right? Now, what will be the ratio? Again, here only I have wrote ratio is equals to, see, ratio is equals to non-terminal nodes upon total number of nodes, right? This is the ratio. So, sorry. So, what is non-terminal nodes? Okay, non-terminal nodes upon total number. So, this formula we have derived. That is non-terminal is equals to nodes is equals to total number of nodes minus terminal nodes. Okay, so how, so basically I will be writing ratio is equals to, we have initialized this with total number of nodes with t, right? And and leaf node, that terminal nodes with L. So T minus L upon, what is the ratio? Total number of nodes, that is T. Okay. So if we solve this further, we will be getting 1 minus L upon T, right? Now, what we will be doing, substitute the value of L and T. Okay. Now, ratio is equals to 1 minus value of L, k raised to power n. So sorry, k raised to power n upon k raised to power n plus 1 minus 1 upon k minus 1, right? This is the value. Now, if we observe here, there is one observation of k raised to power n plus 1 minus 1. This value approximates the k raised to power n plus 1 because it is totally dependent on n. Okay, it is totally dependent on n. Now, when the value of n increases, then there is no any difference between means there is no any difference of minus 1 or plus 1. Okay, because this number becomes so much large that we can ignore this minus 1. So for that reason, we consider k raised to n plus 1 minus 1 is equals to or equivalent to k raised to n plus 1. Okay, now, so what we will be doing here, we will be doing equivalent 1 minus k raised to power n. This k minus 1 will come upside. Okay, and this will become k raised to power n plus 1. Now, this k raised to power n and this k raised to power n will be okay. Now, what will be here? K minus 1 upon 1. Now, we will be solving it here. what is the answer? 1 minus k minus 1. So 1 minus k minus 1 upon k, right? So which equals to taking this k as common, so k upon k minus k minus 1, and this minus, so bracket will be there. Okay, so this will become k minus k plus 1 upon k. So this k and k, this k got cancelled. So what will be the answer? 1 upon k. So let's see the option. 1 upon k is so C is our correct answer. I will write it. Answer 1 upon k. So it was somewhat tricky question, but if you know the formula for total number of nodes and to total number of, or to find the leaf node, total number of leaf node in k array tree, if you know these two formula, it was very much easy question. Just some simplification was required for that. Okay, now let's move to the fourth question. So the fourth question is, in a class definition with 10 methods, to make the class maximally cohesive, number of direct and indirect connection required, the methods are. Okay, so what it is telling that we need to okay, class maximally cohesive. So first we will see what is cohesive. So cohesive, okay, so cohesive is how strongly methods of a class are related to each other. So if there is any class, now there is one class which has 10 methods. So what is cohesiveness? That all these 10 methods are strongly related to each other. It may be indirectly or it may be directly. So we need to find how much there should be the direct connections and indirect connections. Okay, maximally cohesive. To make the class maximally cohesive, how much direct and indirect connections are required among the methods. Okay, so in the options they have given direct and indirect connections. So what is cohesiveness? How strongly methods are connected or related to each other. Okay, so for maximum cohesive, every method of the class should be connected to every other method. Okay, either it will be directly or indirectly. So if we want to uh, if we want every pair of method connected, means if we want so as we have to make maximally cohesive, then what we have to do is all the pairs should be all the method pairs should be connected. Okay, so for the direct connection, what we will be doing, direct connection we can find using NC2. Okay, and what is N? N is number of methods. So in our question, total number of methods are given is 10. So 10C2 is our answer. So how we can find? So 10 factorial upon 8 factorial into 2 factorial. Okay, now for this I will be writing the formula that how I have solved this. So it is basically for NC2, it is n factorial upon n minus 2 factorial into 2 factorial. So using this formula I have solved. So 10 factorial, so I can write this as 8 factorial into 9 into 10 upon 8 factorial into 2. Factorial of 2 is 2. Okay, this 8 factorial gets cancelled. 2 ones are 2, 2 5s are 10. So what will be our answer? 9 5s are 45. So 45 is our answer. So 45 direct connections are required to make the class maximally cohesive. Okay. So uh, now there are two options. Now we can eliminate A. Okay. Then C. Now B and D now are the candidates. But now one thing you can observe, we have made the direct connections of the methods. Means from one method to all 9 methods we have made direct connections. Okay, 2, 3, 4, 5, 6, 7, 8, 9. So for all these methods we have made the direct connections. So there is no meaning to make non indirect connections. Okay, so how much? 45 direct connections are required and 0 indirect connections are required to make the class maximally cohesive. So 100% correct answer is B. So answer will be 45 comma 0. Okay, this was very much simple question. Now let's move to the fifth question. So in this we are given with you one pseudocode. So it is asking the cyclomatic complexity of the above code. So we need to find the cyclomatic complexity. Now let's see what is the cyclomatic complexity. Okay. So basically the cyclomatic complexity is a software metric which is used to measure the complexity of a program in control flows. Okay. In control flows we are using this. Now it is very much simple question. If you know the cyclomatic complexity, in just 10 seconds you would be able to solve the question. So I will be writing Cc. Okay, cyclomatic complexity. Cc is equals to, we can write number of independent, okay, number of independent paths through the program. Independent paths through the program. Now here we will be using one formula. The formula name is McCabe's formula. Using McCabe's formula, we can solve this question. Okay. Now, but we don't need McCabe formula. Okay, sorry, we don't need McCabe formula for this. Using directly we can find. So what we have to find in basic, what we can say in basic language, what is cyclomatic complexity is number of decision points. If you know this much also, you can solve this question. Number of decision points plus 1. Now what is decision points? The program where we are taking any decision. Okay, now if we observe the formula here, in while loop we will be taking two decisions. Okay, so this is one decision point, while loop, that is I minus k minus 1. So I will be writing here decision points, which are the decision points in the formula, in the code. Okay, first one is while I minus I is less than k minus 1. This is the first decision point. Which will be second? So basically what is decision point? From where we can find the program flow, means where the program will flow. Based on that condition, the program depends whether it will satisfy these conditions or not. Now second decision point will be this second while loop, that is while So it is totally dependent. Now see, if this first loop means the condition was not satisfied, then what would have happened? This all loop will get ignored, right? This now means code only not will run. Now this second one, while j is less than k, if now see the program flow. The program flow comes here. Now here it will check the conditions. If it satisfies, it will go inside this while loop. Otherwise, it will go from outside. Okay, it will ignore that and directly go below. So this is the second decision point, and third one is the if condition, because here is also one decision point. Here is also two decisions are there, whether to execute this code or not. Okay, so how many decision points are there? 3 and plus 1. So 4 is the correct answer. So option number C, that is 4, is the correct answer. It was very much easy question. Now let's move to the next question. So it is from operating system. Raymond's tree-based algorithm ensures. Now, what is Raymond's tree-based algorithm? First, we will be seeing this. Now, so Raymond tree-based algorithm is mutual exclusive algorithm. Now, what is mutual exclusive? I will be writing here. Mutual exclusive algorithm. Okay. Now, what I will be doing is, मैं आपको रेमंड्स ट्री बेस्ड एल्गोरिथम आपको समझाऊंगा. बेस्ड ऑन दैट यू विल गिव डायरेक्टली द आंसर. आपको मेरी जरूरत भी नहीं पड़ेगी ABCD में से कौन, आप डायरेक्टली आंसर चूज करोगे और वो 100% करेक्ट होगा. बस ये सुनो, म्यूचुअल एल्गोरिथम है. नाउ म्यूचुअल एक्सक्लूजन क्या है? म्यूचुअल एक्सक्लूजन मीन्स नाउ दिस critical section. What does the mutual exclusion tells? That in a critical section, at a time, there will be only one process. No two or more process are allowed in critical section. So this is known as mutual exclusion algorithm. Okay. Now, this algorithm is token based. Okay. This algorithm is token based. Now, that is, if you have token, if the process have token, then only the process is allowed to go in critical section. Okay. Now, what is critical section? Critical section is it is a part of a code where shared variables are present, in which shared variables are there on which the values of the output depends. Okay. Now, only one process allowed in a critical section, that is mutual exclusion. What is this then? Token based algorithm. That is, if the process is having the token, then and then only it is allowed to go in a critical section. Now, second question in means the first question arise will be that as it is token based, if the process has token, then means many process can bring the token. But what is that? There is also one loophole, that is, in a system there is only one token. So in a critical section at a time there will be only one process, because in a system there is only one token which will be allocated to only one process. So there will be only one process in a critical section. Okay, now this after this, suppose process P1 goes to critical section. Okay, now its work is over. Then what we will be it will be doing is it will be passing that token to the next process, which will be which will be in the request queue. Okay, which will be in request queue. Hmm? Now that to front side, not right side. Okay, front side of request queue, it will be sharing, it will be passing that token. Now due to this there is no problem of deadlock. Okay, there will be no problem of deadlock because the token will be allocated by any of the process. There is no any problem. But there is one more problem. There is problem. That problem will be of starvation. Now suppose this P1 process goes in critical section. Okay, and it has uh, in the problem, or in that, if it is too much big problem or too much big program to run, so what will happen, other remaining process which are inside the request queue will go in starvation, because it will take lot of time to come out. So there will be problem of starvation, but it will be the deadlock free. Now this is all about this algorithm. Okay, now you only answer what means, you only tell me in the comment section what should be the answer. Okay, I will leave this answer. Okay, now let's move to the next question, that is seventh question. So the master theorem, now this question is from algorithms. Okay, the master theorem assumes the subproblems are unequal sizes, can be used if the subproblems are of equal size, cannot be used for divide and conquer algorithms, cannot be used for asymptotic complexity analysis. Now, master theorem, it is a framework for divide and conquer algorithms. Remember, master theorem is framework for the divide and conquer algorithms. Now, what is this divide and conquer? Divide and conquer means we are given with the problem. Okay, we are given with very much large problem. Then what we have to do? We need to make the sub problems of that, or we can say we need to divide that problem into sub problems of equal size. Okay, remember this equal size, because we need to divide all the problem into sub problems, which will be that is, all these sub problems will be of equal size. Okay, so as they are of equal size, and we need to make the problem as smaller as that, means as small as smallest, because if we make that problem smallest, that is we can solve that problem in just one or two steps, then we can consider it as the smallest problem. And after solving all that sub problems which can be solved using one to two steps, and after merging or after conquering or after merging all the results of that sub problems, we get our desired output. This strategy is known as divide and conquer. Okay, what will be that? Divide problem into sub problem, right? Then in such a way that the sub problem can be solved in just one to two steps, and after that merging the output of all the subproblems to get the desired output. Now its best example is binary search. Okay, now for the master method, the problem should be in the form of, or it should be applicable, it will be only applicable if our recurrence relation is as follows. Okay, what will be that? T of n equal to a into T of n upon b plus function. Okay, now what is this a? A is equals to number of subproblems. Okay, and what is b? Factor by which problem size reduces. Okay, and what is this f of n? F of n is cost of divide and conquer, because the time also required to merge means to split these problems into subproblems, then after that, after getting its output, we need to merge them, so this cost. Okay, now its best example is binary search. So recurrence relation of binary search is binary search, which is equals to T of n equal to T of n by 2 plus order of 1. Okay, so what does this mean? That is, number of subproblems will be 1. Then what is the factor by which we are reducing the problem? Is by 2. That is, for in binary search you would have observed that array means for every iteration we are reducing the array by 2. Okay, means half of. Okay, for every iteration the array becomes half. Okay, now what is this order of 1? Order of 1 is to find the mid, to compare whether the mid is greater or whether the mid is smaller. So for this, order of 1 is required. If mid is found to be the target, it will return accordingly. Okay, now let's get to the question. So the master theorem assumes the sub problems are unequal size. Wrong. Sub problems should be of equal size. So can be used if the problems are of equal size. Yes, 100% correct. Cannot be used for divide and conquer algorithms. False, because master theorem is a framework for divide and conquer algorithms. Cannot be used for asymptotic complexity analysis. False. It can be used. Okay. Now let's move to the next question. So the minimum height of an APL tree with n nodes each. So now we need to find the minimum height of the ABL tree. Okay. Now let's see what is ABL tree. Now ABL tree is like a binary search tree. Okay. ABL tree is like a binary search tree, means a binary search tree with self self balancing factor is known as ABL tree. Now what was the problem in binary search tree? How does it differ? Now to find any element in binary search tree, what is the time complexity for BST? BST is order of n. And for AVL tree, it is order of log n. Now why this is so? Because in binary search tree, what is binary search tree? In that, if the element is less than root node, then we put that element to the left side, okay, of the root. And if the element is greater than root, then we put them to it to the right side. But what does the AVL tree do? AVL tree has balancing factor which which height, okay, height differs. Which differs of which height differs by almost 1. Means for every, if the height difference is greater than 1, then it will be balancing, self balancing the tree, that is the root will change. Okay, in that we use rotations. Using rotations, that is LL, LR, RR rotations, we can change the root, so it becomes the balanced AVL tree, and we can find any element using order of log n time complexity. So as we have to find minimum height of APL tree with n nodes, one observation is there. Minimum height means perfectly balanced tree, APL tree, okay? And if the maximum height is there, then we say balancing allows a skewed structure. Okay, now minimum height formula is n equal to 2 raised to power h, and here minus 1. Now what is this h? H is the height and is nodes. What is this? I will write here. N is number of nodes, h is height. Okay, height of tree. Now using this, okay, n is equals to 2 raised to power h minus 1, but no any option is matching. All the options are in the form of. Now one mistake is there. Make this 2 is to the base, okay, This 2 is also to the base. This 2 is also to the base. This 2 is also to the base. Okay. That is now using logarithm. What we will be doing, 2 raised to power h is equals to n plus 1. Okay. Taking log from both the sides. What will be the log? Log 2 equal to log 2 n plus 1. So this will become 1. So h is equals to log 2 n plus 1. Let's see the option. So there are two options, that is floor and ceiling. So for this we will be using ceiling function, because floor function is partially true, but ceiling function always gives us the minimum height. Okay, but for some of the conditions, floor function gives the false result. So correct answer is ceiling function. Now let's move to the next question. So in this one, tree like structure is given, and we have to find the in order successor of 15 in the given binary search tree. Now in binary search tree, in binary search tree, what is in order? Do you know what is in order traversal? Do you know? In order traversal means just arranging. It was so much easy question. That means anyone can solve this question. What is the in order of binary search tree? Is the sorted list or sorted elements. Okay, in ascending order. So let's write the ascending order, that is only the in order of binary search tree. So what is that? 2, 3, 4. Then 2, 3, 4 is that. Then 6, 7. After 7, there will be 9. Then 13. 13 after 15. After 15, there will be 17. Then 18. Then 20. So what was the question? What is in order successor of 15? Successor means after 15 which element is will be present in order. So answer is 70. So C. C is the 100% correct answer. So the answer will be 70. It was so much easy question. Now we are given with one circuit, and the function by the network above is okay. Now we need to find the function for this. So as we can observe here, this is NAND gate. Okay, this is NOR gate, and this is AND, this is also AND, and this is again NOR. Okay, NAND gate, which can be written as, so I will be writing here A B bar, and with E. Okay, so A B bar and this AND. So here equation will become A B bar and with E. Okay, what will be here? Here will be EF, right? And what will be here? Here it will become C plus D bar, and here will be F. Okay, so finally, what will be the final value? So what will be the final value? I will write here that will be AB bar E plus EF plus C plus D bar F. Okay. Now, and there is negation, and there is whole negation. Okay. So after doing this, we will be getting AB bar and E bar like this, dot EF whole bar, then and C plus D whole bar dot F of whole bar. This we will be getting. Now this will become AB plus E bar. Okay, this will become E bar plus F bar. These are the rules in logic gates which you need to know. Okay, this becomes C plus D plus F. Now finally this will become, how we can write this as E bar, and E bar is common, so here is also E bar, here is also E bar, so E bar plus A plus so A and B F bar. This is one answer into C plus D plus F bar. So any option should be matching. So answer is B, which is 100% correct answer. Okay.